Math Man!
Alright students, welcome back to Math Man's Algebra Academy. This is Chapter 2, Lesson 6, Solving Absolute Value Equations and Inequalities. Let's get started. Absolute value equations do have a trick. They're going to make your life a lot easier. So here's the trick. First, you're going to isolate absolute value on one side of the equation, just like you would for a variable. Now, if the other side of the equation, once you've isolated it, is negative, there is no solution. There's no scenario where an absolute value will ever be negative. So, next you're going to write the equation twice, once as a positive and then as a negative, and we'll explain that here in a moment. That's because whatever is in between the absolute value lines could be positive or negative. So, then we're going to solve. If the absolute value equation equals 0, there is only one answer. But if it's a positive number on the other side, there will be two answers. Let's take a look at an example. Alright, so now we've got our first example. We're going to be solving this for W. Negative 6 times the absolute value of W equals negative 12. So the first step in this is to isolate the absolute value, again, as if it was a variable. So negative 6 times absolute value of W, so we're going to do the opposite thing and divide by negative 6. When we do that, we end up with just absolute value of W on the left side and positive 2 on the right side. Now it's not a negative, so this is a possibility. So we're going to write this twice now, the positive and the negative. So W could be 2, or W could be negative 2, because the absolute value of negative 2 would also give us positive 2. Since they're already solved, we don't have to worry about that step, and we have our two answers, W equals 2 and W equals negative 2. Pretty easy, right? Both are correct answers to this question. Let's move on to example 2. Now we're solving for x. We have absolute value of 3x plus 15 is equal to 0. So normally we would isolate the absolute value, but it's already isolated. That makes our step easier. Step 2 is to write it as a positive and a negative. So here's what that looks like. 3x plus 15 equals 0. Now, the reason we said earlier that there's only one answer when it's a 0 on the other side is because you can't write a positive or a negative 0, so we just write it once. Now we have to solve. So, just like any other equation, we're going to subtract 15 from both sides, which leaves us 3x equals negative 15. Then we divide by 3, leaving us with x equals negative 5. So that's our one answer, guys. What do you think? Not too bad. Let's try another example. There is only one correct answer to this question. Let's try the next example. Alright, so now we've got example 3, solving for u. Now we have a pretty crazy one here. We have 4 times the absolute value of 2u plus 3 minus 4 equals negative 8. So, first step is to isolate the absolute value. Now I know this looks crazy, but it's going to be okay. Just breathe and take it one step at a time. The first thing we have to do is add 4 to both sides. That will leave us with 4 times the absolute value of 2u plus 3 equal to negative 4. Then we're going to divide by 4 on both sides to get the absolute value all by itself. So now we have the absolute value of 2u plus 3 equal to negative 1. Now, look what we have here. We have a negative on the other side of the absolute value equation. And we also know that an absolute value can never equal a negative value. So, there is no possible solution to this equation. So, what we're going to write down is no solution. Good job. Let's do the next one. Now we're going to talk about absolute value inequalities. Just like equations, they're going to be pretty similar. First, here's the trick. We're going to isolate the absolute value on one side, just like a variable, again. Just like equations. So, then we're going to write the inequality twice, like we did with equations as well. One time as a positive, and then as a negative. However, this time, inequalities, we have to flip the inequality sign on the negative. That's because whenever it's in between the absolute value lines is positive or negative. Let's give one a try. Alright guys, example number 4, solving for z. We have the absolute value of z is less than 3. Now normally our first step would be to isolate the absolute value. However, that's already been done for us. How about that? So step number 2 is to write it as a positive and a negative. Let's see how that looks. First we start with z is less than 3. And then we have z greater than negative 3. Remember on the inequalities we're going to actually flip the inequality sign and make it negative. So we have two answers and they're right there. These are both correct answers. And now we have to graph them. So the easiest way to do this is to put them in smallest to largest form. So check this out. Z minus 3 is on the left and z less than 3 is on the right. So if you can tell, these inequalities are going towards each other, so that means it's going to be an AND scenario. So since they are not equal to, we have to put open circles at negative 3 and at positive 3. Then the line is going to go between those two circles, making it the AND inequality. Here's your answer. Alright, now we have example number 5, solving for y. We have absolute value of y minus 12 is greater than or equal to negative 10. So our first step once again is to isolate the absolute value as if it was a variable. So we're going to add 12 to both sides, and that leaves us with the absolute value of y is greater than or equal to 2. Second step is to write the positive and the negative, remembering that we have to flip the sign on the negative side. So we have y greater than or equal to 2, and we have y less than or equal to negative 2. So that's our answers. Both of these are correct. So we put them in the right order, with the smallest one to the left, largest one to the right, so we can get a better picture of what we're looking at to graph. Then we're going to graph them. So we put a closed circle now at negative 2 and then at positive 2. And we can see from the way the arrows are going and the way it's going to satisfy this inequality, the arrows are going to go away from each other, meaning it's going to be an OR graph. So it's y less than or equal to negative 2 or y greater than or equal to 2. Now we have example 6. It's the last one, solving for u. We have 3u plus 12 absolute value greater than 3. So once again, we're going to isolate the absolute value, but in this case, it's already been done for us. So we have step 2. Write the positive and the negative side. So we have 3u plus 12 is greater than 3. 3u plus 12 is less than negative 3. Now we're going to solve each side. So we subtract 12 from both sides. We get 3u is greater than negative 9. Then we divide by 3 to get u is greater than negative 3. On the right side, we again subtract negative 12. We have 3u less than negative 15. Dividing by 3, we find u is less than negative 5. So once again, we're going to put these in the right orientation. So we have the lower number to the left and the higher number to the right. Again, you can see that these arrows are pointing away. So we're going to graph them anyway. We have negative 5 and we have negative 3. Since these arrows are going opposite directions, this is an OR statement. So we're going to have a negative 5 arrow going to the left and negative 3 arrow going to the right.
All right, students, that's one more lesson down in the books. So if this video has been helpful to you, please like the video, subscribe to the channel, and we'll see you next time on Math Man's Algebra Academy. Until next time, keep the math mathing.